Hey there's Math 6, Unit 3, Lesson 3, measuring in different size units. Okay, so again, we have another activity here that requires you guys doing some work in your classes with some different stations today. First of all, we're going to move past the first activity and look at the second one, which is on measurement stations. And there are basically 4 different stations, or 5 stations, sorry, that your teacher might have set up today in class. We'll kind of run through a few of those together. I can't do them all. I don't have all the stations here while I'm filming. But let's see. In the first one, it said that you had a station where you had a large cube is 1 cubic inch, and want to know how many of these cubes fit basically inside of a box. You had essentially a box of some sort, and when you look in that box, you're going to try to fill it with those 1-inch cubes, and then you're also going to fill it with 1 cubic centimeter things too. So we're looking at small cubes and large cube, and one was the size of an inch, and one was the size of a centimeter. So in terms of the inch cube, it might look something along these lines, something this size here, but the centimeter cube are more like what you maybe used for counting back when you were in maybe younger grades, second, third grade. So they're those smaller ones there, and if you have a whole bunch together, they make a little rod of 10, but they're going to be smaller than that there. The idea is that what you wanted to see was that when it came to the volume of the box, you were going to have fewer of these compared to this number. So this would be kind of a smaller number. I'm making this up right now, okay? So maybe you had 10 of these, but in terms of cubic centimeters, maybe it was more like, I don't know, I'm just going to say 30. This is totally made up. This is not real numbers. It's not accurate measuring. I'm just saying you'd have a smaller number of these because they are larger and they take up more space faster than the centimeters would. And that's the idea what you would see with station number 1, is that an inch, because it's larger than centimeters, takes up more space. And so inches are greater than centimeters, which means you actually need more of these in order to have the same size as these ones. You need less of these to be the same as that size, filling up that same space there. Your teacher then gave you something to measure in your class, right? Gave you a distance to measure, maybe from your seat to the wall or across the window. Okay, and you wanted to use a meter stick to measure that length, and then use a ruler to measure it as well. So what we're doing here is we're comparing meters and feet to see the difference between those two lengths of measurements there. And one thing we know is that meters are actually longer than feet. Okay, so it's going to take us more feet to, when you're comparing numbers, you'll have a greater number here than that one, or you might have less meters to be feet. So for example, if something was 1 meter long, that's going to be about 3 point something feet. So this number is greater than that number, but meters is a larger measurement tool. So when this tool is a greater measurement than this measurement, then you need more of the smaller measurement numerically in order to make up the difference there. Okay, so kind of a funny way of saying that, but all right. Station 3 is called, if not using real water, open this up here, and there's a video there for us to watch to be able to compare quarts from a gallon jug as well as liters from a gallon jug to compare the difference between those two things. And we actually do have this here on the website for our textbook. Just want to pop that up there so we can see it real quick. And we have these kids here who are going to show you how you take a gallon of water and they're pouring that into the funnel into these quart containers. I imagine these are 4 quarts. And over here we have, looks like liters, which we'll do in a bit there. So we can see they're carefully pouring that in there and trying to spill any all over the table. Alright, so we're filling. It's going nice and slow. They're doing a great job. Good job, kids. Way to go. And then we're going to go to the next one and hopefully go a little faster. That was faster. I like that. Cool. And the third one. And there it is. And the fourth one. Cool. So we can see from here that 1 gallon will fill exactly 4 quarts. Kind of cool. Good to see that and make that happen. Now, how about gallon of liters? How does that work? So here's another gallon. We know that this was 4 quarts equals 1 gallon. When we take the liter, see what happens. There's 1 liter. There's 2. There's 3. And here comes 4. What's going to happen? And oh, so close. Just so close. Not quite full, is it? Right? So, which is larger, a quart or a liter? So when we look at this here, we have liters in this case, we have quarts here, and we can tell that quarts are holding a whole gallon worth of liquid compared to the liters, right? So our quarts are going to be, well, of course, I say larger. A liter is going to be larger because it's going to be holding more, it has more space to fill up, right? It can hold a whole gallon plus more. So this is a gallon, and for 4 quarts is a gallon, but we can put that plus more in there. So because there was space in that last bottle, right? Because there's space in that last bottle there, that space tells me that there's more. That liter is a larger volume measurement than a quart. So how many times can you fill that? We can put 4 in there. 4 quarts go in there. And for liters, how many gallons go in there? We end up with 3, maybe let's just say 3.5. But it's more like 3 2/3. So 3 2/3. Okay. Now notice again that because this number, the quarts is less, we need more quarts to equal the same amount of liters. That's a terrible drawing. Maybe I should write nicer, as people comment all the time. That's okay. So 3, oh my goodness, and 2/3. Let's just say 3 2/3 were filled there. All right, and so that's what we did in terms of containers there. So, cool. And our last activity here, it's our one we're going to do, we have a scale, and it wants us to compare, in this case here, ounces, pounds, grams, and kilograms. And so to do that, what we do is get my phone going the right direction here, and we'll go to, go to this one here, and we go to GeoGebra, and we see that here's an object, and we're going to go ahead and we're going to click a pencil right there. We're going to put 1 pencil on there, and in terms of ounces, I can slide it up and say that it's going to weigh 0.31 ounces. When we look at pounds, it's 0.019 pounds. In terms of grams, we'll drop that down to there, it's 9 grams. And in terms of kilograms, 0.009. So what we're showing is just the difference in these different weight measurements, right? An ounce is less than a pound, and a gram is going to be less than that as well, less than both of those. And so that's what we have. So in a sense, the larger the number that we see here, based on this object, the smaller the unit of measurement actually is. So this is our smallest. So if you're going to go small to large, we would say this is our smallest. Our next smallest is our next biggest number, which is ounces, followed by pounds, followed by kilograms there. We did 2 objects. Let's just put, I don't know if it's object number 2, sorry. Let's just do a milk jug. Put a milk jug up there. So kilograms, it tells us that kilograms are just going to weigh 3.9. 3.9. And so we would anticipate that if I'm going to turn that into grams, because kilograms is a greater measurement than grams, this number should increase, right? It should be a bigger number than that one. So let's see if that's true. Put it up one, and sure enough, we have 3,901. Okay? Now we also know that grams are less than pounds. So if I'm going this way, thinking about this, grams less than pounds, which means that the pounds number, whatever it should be a smaller number than the grams, right? Because pounds are greater than grams, so because it's greater, my number should be smaller. So let's see if this number is smaller than 3,000 when I change it to pounds. That's tons. Yep, here we are, 8.6. And then when I compare pounds and ounces, pounds are bigger than ounces. Because pounds are bigger than ounces, the ounce number should actually increase, and the 8.6 should go up compared to that number when I flip the ounces. And sure enough it does, 137.6. Alright, so that's the idea there. And you can do some other numbers and take care of that on your own. Alright, and then the last thing we had here on activity 5 just was having you take a look at some salt and looking at milliliters and teaspoons, and again comparing these 2 units of measurement together as well. Okay, so the same kind of idea to compare how those things relate. All right. And then when you're finished looking at all those, the activity really for today in class was to then do some comparison to talk about what was different between a cubic inch and a cubic centimeter, what's happening between feet and meters, quarts and liters, and so on and so forth. So that was the activity. So as we kind of sum that up there, we say that the size of the unit we use to measure something affects the measurement. If we measure the same quantity with different units, it will take more of the smaller unit and fewer of the larger unit to express the measurement. For example, a room that measures 4 yards, 1, 2, 3, 4, here's yards, in length will measure 12 feet in length. It's the same exact distance, but because we say that a yard is greater than a foot, we need to have the number is going to be a smaller number of yards compared to a greater number of feet, right? We have 4 of these, and we have, in this case here, 12 of these. 12 is a bigger number than 4, but that has to be the case because yards are greater than feet. So just an idea how that works there. Kind of cool. So that's it for the lesson part of the day. We're going to pause there and give you a moment to get your homework started here, as we're just kind of talking about different measurements with different size units. So we'll pause there and we'll come back in just a second. Okay, welcome back. Decide if each is a measurement of length, area, right? So that's length. Here's area, volume, right? Volume, or weight. I don't know how to draw that one, so it's like a scale, right? So we'll do a scale, something like this. That's a terrible scale. Whatever. Okay, so we have centimeters across a handprint. We're going to call that a length. Square inches of paper. That is an area with square inch. For gallons of water, that deals with the volume, right, of the tank. Okay, pounds, it's going to deal with weight. For feet across a pool, we're talking about length. Ounces in a bag of grains, so ounces is going to be a weight. Liters deals with a volume, and square feet deals with an area. All right, that's what we have there so far. Let's take a look at number 2. Claire says this classroom is 11 meters long. A meter is longer than a yard, so a meter is longer than a yard. So if I measure the length of the classroom in yards, I will get less than 11 yards. Okay, so remember we said before, if we compare a meter and yard this way, the meter is greater than a yard, right? So because a meter is greater than a yard, then this number should be, if we're looking for equal things, will be a smaller number than this number. I will have a greater number of yards than meters to make them equal. So if I have 11 meters here, and I know that meters are bigger than yards. Okay, this is not really greater than less. I'm just saying that these are meters bigger than yards. Don't worry about the numbers right now. Whatever a number I put here should be bigger than, right? I need yards will be more than 11, right? So she says I will get less than 11 yards, and that's not going to be true because yards is a smaller measurement tool than a meter, so I actually need more of them in order to get to the length of a meter. Again, here's your idea. This is yards, and a meter's here. So I had 11 of these and 11 of these. This is going to be a lot longer than that. It'll take additional ones. I'm short some space, so I need more. Okay, and that's the idea. Number 3. Tyler's height is 57 inches. What could be his height in centimeters? And explain your reasoning. Okay, so what do we know? We know that inches overall is a greater measurement than centimeters, right? So that means that if I'm going to be moving from inch to centimeters, I'm moving from inches to centimeters, the centimeter number, because a centimeter is a smaller measurement than inches, should be a greater number. So I need a number bigger than 57 is what I'm looking for here. So when I get to the 22, that's too small. 57 is exactly the same, so I don't think it's going to be exactly the same. They're different measurements, so that's a no. That's greater, so that makes sense. That one is enormous. So they're both larger, but in terms of reality, that's going to be closer because a centimeter is like this, and an inch is like this. So it's probably not going to be 3,000 compared to 57. Because really, a centimeter is like 2.2 inches, right? Or 2.2 centimeters equals about 1 inch. So it's like double plus a little more. So that looks about right. That's about 60. Doubling it gets about 120, and a little more certainly looks like about 144. So that's my logic there for how that would work. Okay, let's look at another comparison. Here we have a large pot. Soup pot holds 20 quarts. What could be its volume in liters? Okay, so first of all, we have quarts and we have liters. We saw before that quarts are actually smaller than liters. We looked at that video with the blue stuff coming from the gallon, and liters were bigger. So if I have 20 quarts here and I'm turning quarts into liters, because liters is a bigger measurement tool, I should have a smaller number, right? Liters are greater, so I should have a smaller number than 20. So I need a number smaller than 20 to be about what the liters would be. Okay, now it's not a huge difference though, right? They were pretty close when we looked at the measurement there. Remember, it was like, well, don't worry about it. So when it's smaller than 20, we know that 75 is not going to work. 21 is not going to work. So I'm left with these two. These are both less than 20. But is a quart and a liter, are they significantly different? Not really. You're comparing the size of a reusable water bottle and a Powerade Gatorade bottle. So we're going to probably go with more like 19 is a better approximation there. Okay? Next one. Claire wants to mail a package that weighs 4.5 pounds. What would this weight be in kilograms? Okay, so we have to know. Pounds, which is abbreviated by LBS, that's pounds. Pounds are less than kilograms in terms of their overall like mass, right? Kilograms more. So I have 4.5 pounds over here. If I'm going into kilograms, because kilograms is a greater measurement tool, I should have a smaller number than what I have over here. So a smaller number than 4.5. Looking over here, 4,000, nope. 9, nope. The same number, nope. So the best answer is going to be 2.04. All right, number 6. Some review stuff. Know about 15 baseball cards for $9. So he got 15 cards for $9. Cards and dollars. Assuming each baseball card costs the same amount, answer the following questions. At this rate, how much will 30 baseball cards? So 30 is multiplying by 2. And so 9 times 2 is 18. So we would say it's $18 because we're multiplying by 2. At this rate, how much will 13 baseball cards cost? Oh, sorry, 12. So 12 is not a number that I can see a real quick relationship with, but I can do a couple steps here, right? What I could do is I could either find out how much one baseball card might cost. That's one way of looking at it, right? I could also look and see, well, what about how much something like 3 baseball cards would cost? Why 3? Well, I can turn 15 into another column here, into 3. I like 3 because that's times 1/5. So 9 times 1/5 is going to be 9/5. I don't know how much that is, but we'll just call it 9/5. All right, when I use my calculator, 9/5 comes out to be $1.80, I believe. Let's just double check here. Here's 5, goes into 9.000, goes in there one time. We have 5, we subtract, we have 4, goes into 48 times, so $1.80. So 9/5 becomes $1.80. That's how that's going to be for 3. Why do I pick 3? Because 3 times 4 is 12. So if I do $1.80 times 4, we get 3, 4, 5, 6, 7, get 2, and we're at $7.20 right there. Okay? So we're going to say $7.20 is what it's going to cost, and we're good to go. Do you think this information would be better represented using a table or a double number line? For me, I prefer the table just because it's easier to see how things work there and to do my multiplication up and down the table. And it's just easier to work with. That's just me. And our last one here for the day, it looks like. All right. says Jada traveled a constant traveled 135 miles in 3 hours. Andre traveled 228 miles in 6 hours. They traveled at constant speed. How far do they go in 1 hour for Jada? 1 hour for Andre. So to do 1 hour, we're going to multiply by 1/3. Over here, we're going to multiply by 1/3, and 135 divided by 3, or times third, is 45 in 1 hour. This is times 1/6. This is times 1/6. So 228 divided by 6 is 36. So we have 36 hours there. So Jada traveled 45 hours. Andre traveled 36 hours. And in terms of who traveled faster, we would say Jada, who went 45 miles in 1 hour. That's it. Have a great day. We'll see you next time.